Good day, ladies and gentlemen. Yeah, welcome to Okunlola Academy, wherever you're watching us from around the world. Uh, Today we are going to be looking at performing unit root tests in EView using the deterministic parameters of intercept, intercept and trend, and of course none. Now, the essence of today's video is to ascertain what parameters is desirable when we are performing or estimating our series under the unit root estimation analysis. Now, having said this, in the previous videos, we analyzed the process by which you can determine whether to subject your series, your data, to a trend analysis, or whether you subject that data to intercept and trend analysis, or simply that you use none within the EView environment. And one of the things we said is that the general consideration before you can subject this data to unit root test is the fact that you need to first and foremost visualize the data. And when you visualize this data, whatever trend the output shows inform the theory. Then you have to find whether it either support the theory or is inverse the theory. Whatever outcome the output of the visual shows then determines the parameter of the unit root test that's going to be performed. So quickly, we'll open the data before we go there to the EViews environment. Now, looking at this data, we see a data of 1, 2, 3, 4, and 5. Now, I'm going to do a visual plot of this data, just as you have seen here. So the visual plot, as shown here, already indicates uh, the the visuals for the data. Now, as it were, uh, the data is GDP per capita growth. GDP per capita growth. What are the expectations, or what are the consideration in this aspect? If you look at the visuals here, it shows that the data point fluctuates around a mean. It shows that the data point fluctuates around a mean. That is, it is a non-zero series. You could say that it goes above the zero line and it also comes below the zero line. However, there's a bit of us maintaining a stable trend within a period of time compared to when it uh, nosedive from that period. So we say that this data shows that it fluctuates around a mean value, and that um, that is not is a non-zero uh, data, but also it appears that it's stable over time and captures the non-zero average level. So we ought to perform this visual to ascertain whether or not in our EView environment we are to use either the intercept and trend, and of course the none. Again, in that video, we also conclude, we discussed that looking at the visuals as well, you have to also ascertain the theoretical underpinning, whether the GDP per capita growth is meant to be linear, or it's meant to be non-linear, or perhaps it's meant to exhibit a kind of is a random walk, as it were, or constant mean around the theory. So whatever the theory says determines, again, or perhaps support this visual, then you cannot decide to run your unit through test. Having said that, we just go through the unit root test, knowing fully well that that data exhibits an intercept-like kind of visual based on the steps that the data series exhibits. So quickly, I'll just take that because that was the data set that I visualized now. So I come here, I open the data, come here, open the data. So then I go to view. Then from view, I come to a unit root test. Okay, so from the unit root test, the data shows that it is an intercept. It has a characteristic of an intercept series. So already, I just pick the intercept, right? And again, I'll leave this as the automatic selection as it will, while I also leave this level. So I just go to OK. All right there. So this is our output as it is. So by so doing, we see that um, GDP per capita growth becomes stationary at order, at level, at the intercept parameter. So looking at this environment, we see that this value, its absolute value is greater, that's the t statistics now, is greater than the critical values of 1%, 5%, 10%, whereas it is also the probability is also less than 0.05, which means that this data becomes stationary at its level. Thank you. Bye bye.